Dear students, in JEE 2009, this question was from chapter Electric Charges and Electric Fields. And the question is, let rho r, that is equal to q upon pi capital R raised to 4 into small r, be the charge density distribution for a solid sphere of radius capital R and total charge q for a point P inside at a distance r1 from the center of the sphere. The magnitude of electric field is option A 0, B q upon 4 pi epsilon 0 r1 square, C q r1 square upon 4 pi epsilon 0 capital R raised to 4, D q r1 square upon 3 pi epsilon 0 r raised to 4. Now see here, for the solid sphere, the charge distribution that is given to you and the charge density, that is rho at r equal to q upon pi capital R raised to 4 into r. And now we have to find the electric field at a point P inside the sphere at a distance r1 from the center. This is our question. So here we can solve this problem with the help of Gauss's theorem. So here first we have to consider a Gaussian surface having radius equal to r1, and suppose the thickness for this Gaussian surface that is equal to dr. And now this Gaussian surface that is enclosing how much amount of charge that we have to find. See here the charge density that is given to you. Now if we apply the Gauss's theorem to this particular Gaussian surface, then we can write integration EdA equal to sigma q upon epsilon 0. Now E is uniform, integration dA. So here the area of this Gaussian surface, that is 4 pi r1 square, sigma q, that is the net charge enclosed by this Gaussian surface. So here charge per unit volume, that is rho. So charge on the volume of this particular Gaussian surface, that is how much. So integration rho dV, right? And this 1 upon epsilon 0 is taken outside the integration. Left hand side is kept as it is, E 4 pi r1 square equal to 1 upon epsilon 0. Now here integration is carried out from 0 to r1. So we can calculate the net charge enclosed by this particular Gaussian surface. Density, that is q upon pi r raised to 4 into r. Now dV, okay, so dV, that is the volume of this particular thin Gaussian surface. So that is 4 pi r square, that is its area into its thickness dr. Now here 4 pi will be cancelled on both the side. So on left hand side we can write E into r1 square, that is equal to 1 upon epsilon 0 pi r raised to 4. And this r and r square, that you can take r cube and they take this q outside the integration. So you can write E r1 square equal to q upon pi epsilon 0 r raised to 4 integration 0 to r1 r cube dr. Now integration of r cube, that is r raised to 4 by 4. Limits 0 to r1. Now substitute first upper limit, then lower limit. Lower limit is 0, so will be 0. So you can write E r1 square, that is q upon pi epsilon 0 capital R raised to 4, r1 raised to 4 by 4. this R1 square and R1 raised to 4 will give you here R1 raised to 2. So you will get E, that is equal to Q R1 square upon 4 pi epsilon 0 capital R raised to 4. So as per given option, our answer that will be C. Clear to all of you?